try to make this as easy as possible because this stuff can get tricky. All right, so we're gonna get through the notes, but we're gonna skip some questions, and we're gonna come back to the beginning, and we're gonna start over from a different perspective. Cool? Okay, cool. We're gonna start looking at functions and their characteristics. When we look at functions and their characteristics, we ignore the y's. I don't care about the y's. We just pay attention to x's and intervals on x's. We like to look at functions from left to right, which is helpful because we are Americans and we do read things from left to right. Not all cultures do, though. So we're going to look at negative infinity on our x-axis all the way to positive infinity. And we're going to talk about what are some characteristics of our function, okay? For example, my function from left to right goes down and then goes up. Cool? I can say that my function is decreasing from negative infinity until 0 because my function is going down from negative infinity to 0. My function is increasing from 0 to infinity. I could say x equals 0 is a minimum. It's a minimum because my function goes down and goes back up. I'll call it minimum locations where functions go down and back up. There's something new that we're going to pay attention to this function. It's curvature. We know that this is a parabola, and we talked about parabolas opening upwards and opening downwards. We are going to, call this parabola. It's going to open up. I'm going to say it curves up. Or a new word to describe a curvature where you're opening up is concave up. Cool. Concave up. That parabola that opens up is concave up everywhere. What else do I notice? The y values are all positive except for at x equals 0. So I could say f of x is greater than 0 from negative infinity to 0 and then from 0 to infinity. Because it's 0 at 0, so it's not greater than 0. Maybe we could say f of x is greater than or equal to 0 everywhere. How about that? That's easy. F of x is greater than or equal to 0 everywhere because all of the y values are positive above the x-axis. Here's another graph of another quadratic. Again, we don't care about the y's, we just care about the x's. Talk about when the function is increasing or decreasing. Tell when the function is positive or negative. Why don't you guys start by telling your neighbors, when is this function going up and going down? When is this function going to produce positive y values and negative y values? Don't worry about being exact, just provide guesstimates. Go. When is it decreasing? When is it increasing? Look from left to right. Go. Okay, it is increasing from negative infinity until 2. I keep going up and up until I get to 2. At x equals 2, I'm going to call that a max because at x equals 2, I go from increasing to decreasing. We'll call a max a location that changes from increasing to decreasing. Decreasing will be from 2 to infinity. We can write these intervals also not using interval notation, but using inequality notation. Just so you know, you could say X is less than 2 is the same as negative infinity to 2. X is greater than 2 is 2 to infinity. Didn't ask you this somewhere, but I'm going to ask you this now. Like, how about let's pick an easy one. When is f of x greater than 0? I translate this to when is my function positive? When do we have positive values? Okay, so when do you have positive values? Tell your neighbors that. You haven't told them that anymore. Yeah, I would probably say from negative 0.5 to 4.5, my y values are positive. Cool? Now, here's something new. I mean, I guess it's not new, but the way we're going to describe it is new to you. This parabola opens down. We can say it curves down. We are now going to say it's concave down. It is concave down everywhere. It's concave down from negative infinity to positive infinity. Why? Because I can just tell. But we're going to talk about how else we're going to be able to tell later when we come back to the beginning of this lesson. Okay. One more. Start with telling me, when is the function increasing? Go. When is the function increasing? When is this h increasing? Original. It's fine. Again, I don't care about the y. My function goes up until, I don't know, negative 2.2. Negative infinity to negative 2.2, I'm increasing. Also from 2.2 to infinity. Is it exact? I don't care. Just like best guesstimate here. That's when my function's increasing. Decreasing would be between the 2 points. Okay, let's just talk about increase. Next question. When is this h of x less than 0? Tell your neighbors, when is h of x less than 0? I would say the values of my graph are negative between negative infinity and negative 4 and from 0 to 4. How we doing? So far so good? Right? Isn't that so bad? Okay, cool. It'll get worse, but don't worry. The next question is, how does this graph curve? How does h curve? We saw from the previous page, sometimes graphs curve upward. Sometimes graphs curve downward. What do you see in terms of curvature here? Tell your neighbors, at least discuss it, so you're thinking a little bit. How is this graph curving? That's what I want you to say. I want you to say, well, Mr. Messner, it looks like we got two parabolas here. Now, what's important is that this would be one parabola. It goes up and down, and you can kind of see that it curves down the entire way. Cool? That portion of the graph is concave down. Got that? So we will say that this portion of the graph is concave down. Then another parabola kind of takes over. It's not a parabola. I don't want to say parabola, but you get what I'm saying here. Right here, we have another parabola that's opening upward. this portion of the graph is concave up. Graphs curvature change, usually. If you're talking about any type of graph that's not a quadratic or linear, curvature is going to change, okay? So, where we change curvature looks to be right here at x equals 0. This, my friends, is called a point of inflection. A point of inflection is when a graph's concavity changes. Concavity is curvature. Okay? Think of a parabola opening upward. That's what you're going to think is concave up. I'm going to use CC up from now on, so I don't have to write concave up all the time. A parabola opens down. It's concave down. Now, what's important is you don't have to have the entire parabola to say it's concave down. If I drew something like this, would you call that concave up or concave down? Concave up. I'd say I'm going down and concave up. If I drew something like that, concave down. Cool? So you don't have to have the entire parabola. You can just have pieces of the parabola, and you can kind of tell how things are curving. Okay, we're going to start with that. Okay? I could make this a lot more complicated, but we're just going to start with that. Here's a graph. Where do you think this graph has points of inflection? Where do you think this graph is concave up? Every tick mark we're going to assume is 1. We're going to go from negative infinity to infinity. Ready, set, go. I feel like your highlights could be confusing, but no. And I feel like you should never say that to your friends, too. That's like number 1. So it wasn't very nice. And yeah. Yes. Great thing about being bald is I don't know if I have gray hairs or not. Yep. All right. What do we got? Where do we think points of inflection are? Where do you think your graph is concave up? Go ahead. Mambo, you're looking at me like you got it. -2 and 2. No. That's what most people think, but like, remember, Mambo, the parabola. This parabola is concave up everywhere. You don't say that it's concave up until the bottom of it, and then it switches concavity. Cool. Everybody, tell your neighbors, why isn't it -2, 2? What is it? It is opening upward here. It switches to opening downward here. Then it switches to opening upward here. I would probably say that the points of inflection are -1 and 1. Cool? All right, so when is the graph concave up? I kind of gave you the answer right there. Negative infinity to -1 and 1 to infinity. Let's go with this one. When is the function less than 0? Answer that question. Say neighbors, when is the function less than 0? Go. Good. When the function y values are negative when the function is less than 0. We're talking about negative y values, -3 to -1, and 1 to 3. Again, you could write this using inequality notation rather than interval notation. So I would write that or this. We're just used to both. Just make sure you're comfortable with both, recognizing both. Either is the answer, okay? Okay, next one. Let's go with, we did negative. Why don't we go with increasing? What is the function increasing? What is the function increasing? Great. Isn't that bad, right? -2 to 0, my function's going up. 2 to infinity, my function is going up. -2 to 0, 2 to infinity. Those are the x intervals in which my function is going up. Are we good? If we're not getting it right, it's okay. It's okay. But it will get harder. How are we doing over here? Yeah? You sure? Okay, more practice. More practice with easy ones. Here we go. I am telling you where the points of inflection are. There is a point of inflection at 1. So right here, you're changing your curvature. I'm not going to tell you what you're changing. So right at 1, at 3, which is right around here, you change your curvature right there. At 4, you change your curvature right around there. All right. First question. When is g less than 0? Again, we look from left to right. We can translate this. What does it mean to be less than 0? We're talking about g being negative. That's probably what I would translate it as. G is negative. G is negative when its y values are below the x-axis. Negative 1 to 2. Cool. Next, when is g decreasing? Go. G is going down. Well, I can kind of see that I have a max here at x equals -1. You guys see how that is a max? It doesn't have to be an overall max. It just is a point where like I go up and then down. That's a max. I could call this a mid. I could call this a max. It's important for your homework. I can call this a min. It doesn't have to be an overall max. It's just like a point where we either go down or up or down. Our maxes or mins. Cool? From a max to a min, I go down. So from -1 to like 1.5. From a max to a min, I go down. From, I don't know, 1, 2, 3.5 to 5. Did you guys say that? Yeah? All right, cool. The next two questions you don't know how to do. We haven't talked about it yet. So I'm going to skip it. I'm just going to ask you, when is G concave up? Different question. Write that on the bottom. When is G concave up? You know when the points of inflection. All right. Now answer when is function concave up. That's semester. Got it. Yep. Shut up, yeah. Watch the rest of it. It'll be great. Okay. When we concave up. When we are opening up, tell your neighbors, go. You know where the points of inflection are? They're telling you where the points of inflection are. Here, I'm opening up. Here, I'm opening up, okay? I would say I'm concave up from 1 to 3 and from, what is that, 5 to infinity. Is it 4? It's 4. 4 to infinity. Cool. Not so bad. We will continue on. Again, we are going to come back. We will not go to the last row of this page. We will come back to the last row of this page. But the questions will start to get harder, regardless of skipping what we've skipped so far. Because sometimes they'll ask you for a combination of two things at once. For example, g less than 0 and increasing. What could that possibly look like if you have a function g that is both less than 0 and increasing? Sketch something that is less than 0 and increasing. Go. If you're wrong, it's okay. Careful. Don't go over this line, because once you go over this line, you are increasing and positive. You have to be down here. I would say negative and increasing could look anything as long as it's below the line and going up. Okay? Curve however you want to. You just need to be below the line and going up. Okay? Cool. Next one. When is g greater than 0 and decreasing? When is g positive and decreasing? Great. Don't care how you curve. You can curve like that. You can have no curve. You could be curving this way. That's fine. I'm above the x-axis and I'm decreasing. Next one. And the last one. Negative and decreasing, positive and increasing. I probably would get rid of this whole part there. Cool. Curvature does not matter. Now it does. For these four, positive and negative does not matter, but curvature does. So, what does something that is both increasing and concave up look like? Ready? I'm going to give you some help here, guys. Go back to our first page. You don't have to flip it. But if you think back to our first page, we had something that was concave up everywhere. This was concave up everywhere. This is concave down everywhere. Split it in half. And you have all four pieces that you need for these four spots. You see how this works? Which of these four pieces is increasing and concave up? Now draw it. That's decreasing and increasing. Give me the right piece of it. There, whoop, don't erase all of it. This piece, I'll label this as number 1, because that's increasing concave up. Going up, curving upwards. Increasing concave down. Well, here's concave down. This is increasing concave down. I'm labeling this as number 2, increasing concave down. Cool? Do the last two if you haven't done them yet. Decreasing concave down, decreasing concave up. There you go. So decreasing concave down, that would be number 3 here. That's number 3. Decreasing concave up, that's number 4. So like, here's your backup. You can always have your like original parabolas and split them in half. And you have like all 4 kind of combinations of increasing, decreasing, concave up, and concave down. What does increasing no concavity look like? Tell your neighbors. That's just a straight line. Cool. The last row, we will skip. We will come back. All right. Let's start and make sure we have the same point of inflection, because it's a little bit like, it depends on how you think about it, look at it, but let's all get the same point of inflection. Where do you guys think there's a point of inflection for this graph? And there's only one. Tell your neighbors, what do you think? There's really no right answers, but I'll tell you what I think. Let's say the function is curving upwards until 2. And then it looks like the function curves downwards after that. So I am going to say that x equals 2 is the point of inflection. From now on, you all will say that x equals 2 is the point of inflection. Okay? Cool. Cool. Now, when is f negative and decreasing? This is the combination. You go back to the previous page. What you got? When is the function negative and decreasing? What would you say? Yep. Great question is, why isn't there a point of inflection at -1? Everybody thinks that these maxes and mins are points of inflection, but they're not. Think of the parabola. A parabola is concave up everywhere. This graph is opening up, including here. Like, if you look at this interval from 0 to 1, would you say that this is opening downward? No, I'd say it's opening upward. So we're opening upward. Okay, we're still opening upward. We're still opening, so like -1 is not a point of inflection, okay, because you're still opening upward. Okay, negative and decreasing. How do we do? How's it going so far? Not that bad, right? Do you think you got it? Yep. Good. Blanchard's right. -2 to -1 and 5 to infinity. Nailed it. This is easy. We are below the x-axis and we're going down. When is f positive and increasing? Zero to 3. You guys get that? That's what I got. Okay. Here we go. When is f increasing, concave up? When is f going up and concave up? Tell your neighbors, what do you get? I got -1 to 2, 2. I'm going up and I'm concave up. It's not starting at 0. I start at a min. The min's at -1. The max is at 3. So -1 to 2, I'm going up, concave up. When is f increasing, concave down? Figure that out. Go. Nice. Here's my point of inflection at 2. I'm going up, concave down from 2 to 3. Cool. Back to the beginning. We just did the easy part. Okay? All I'm going to do, guys, is pretty much give you the same question that you just got and you understood. They're just going to be asked a different way. Okay? Because we're going to start talking about rates. Okay? Rates. And all of my questions now are going to be, when are the rates of f negative and increasing? When are the rates of f positive? When are the rates of f positive and decreasing? These are the types of questions I'm going to ask. They are the same questions you've already answered. Okay? You just don't know them yet. Because what do we know already? What do you know when your rates are negative? How do you translate that? Tell your neighbors how you would have translated that -5 on your quiz. Like, what is the statement you wrote on your quiz if you got the number -5? Y's for X is what we like to say. We know that when your rate, what's another word for rate? Slopes are negative, your function is decreasing. When rates are negative, functions decrease. Okay. When rates are positive, when our rates, which are our slopes, are positive, our function is increasing. So, gotta find the right question. So, how about here for this question? Here we go. Just a made-up question. I'm just throwing this in. We can like write it down or just like pay attention. I can ask, hey, when are the rates of change of f negative? Okay? What am I really asking? Translate. When are the rates of change negative? What am I really asking? The rates of change will be negative when the slopes are negative. Slopes are negative when the function's decreasing. You got that? So if I ask you when the rates of change is negative, you're like, oh, that's the same as when the function's decreasing. I know how to do that. I've already answered a bunch of those questions. Cool? So you would say from 0 to 2 and from negative infinity to negative 2. If I ask you for this one, when are the rates of change positive? What am I actually asking? Rates of change are the slopes. Slopes are positive. The function's increasing. If I ask you when are the rates of change are positive, you're like, oh, the function's increasing. I'm going to look at when the function's increasing. Cool. Now, here's the next thing we need to look at. How are the rates of change changing? -7 to -5 to -3 to -1 to 1 to 3 to 5 to 7. Yes, it's all difference of 2. But you know what I see? Slopes that are going up. Slopes that are increasing. Everybody has a slope generator in their hand, right? Your pencil? Great. Here's your slope generator. Can you, using your pencil, create a slope of -7? What would a slope of -7 look like? Put up your pencil so you create a slope of -7. Yeah, something like that. Now move over a little bit to the right and create a slope of -5 to -3 to -1. Give me a slope of 0 to 1 to 3 to 5 to 7. If slopes are increasing, the function is curving upward. Thanks for the slope generator. When slopes are increasing, a graph is concave up. When rates of change are increasing, the graph is concave up. Negative, that says slopes increasing. I'm sorry, I was like, over here is a weird angle. Yeah, my penmanship sucks already. -5, -4, -3, -2, -1, 0, +1, 2, 3, 4. Those slope values are increasing. My graph is concave up. The same can be done with something that's concave down. What would be the slopes of something concave down? Tell your neighbors, like, give me some numbers for the slopes there. Go. 7, 5, 3, 1, 0. -1, -3, -5. Those slopes are decreasing. We say we're concave down when our slopes or our rates are the same as slopes when they are decreasing. Okay. If I go back to this question right here, and I ask you, when are F rates increasing? You've already answered this question, but now it's just worded a different way. What am I actually asking when F rates are increasing? Tell your neighbors. Rates increase, slopes increase, causes concave up. When your slopes are increasing, you are concave up. This is where everybody screws up. Because everybody sees F, and they see increasing, and they think, oh, I'm going up. Oh, I'm going up. But no. It's F slopes increasing. -3, -2, -1, 0, 1, 2. Those values are increasing. I'm concave up. When your rates are increasing, you are concave up. I'm asking you the same question, but I'm wording it different. If we embrace that, there's going to be like 2 ways to ask the same question, and we're okay with it, then this lesson's fine. But if stuff starts getting crisscrossed in your head, it gets really tricky. Okay. Because I can ask you the following. Sketch something where G is decreasing at an increasing rate. Yeah, this is where it gets tricky. I'll tell you what, it's one of these 4. 1, 2, 3, or 4. Which one is it? Decreasing at an increasing rate. Which one is it?
2.
Oh, that's increasing. No, that's decreasing and increasing. It's close. This is where it gets tricky. Ready, guys? Here's what's going to help you. You're going to write this down again. We already wrote it down. Here is concave up. That is concave up. What are the slopes of that graph? Are the slopes of this graph increasing or decreasing? Assign some numbers and tell me the slopes of that concave up graph. Go. Tell your neighbors. -5, 4, 3, 2, 1, 0, 1, 2, 3. The slopes or the rates are increasing. Guys, you need to put this in your notes 15 times. If your slopes are increasing, the graph is concave up. If G is decreasing, but the slopes are increasing, the graph has got to be concave up. I know it's confusing because it is. A lot of people assume we are going down and faster down because it's like, oh, we're increasing our rate that we're No. We are going down. The slopes are negative. The slopes are increasing. -5, -4, -3, -2, -1, 0. There you go. Those are slopes that are negative and increasing. Does that make sense? -5 to -4 to -3 to -2 to -1 is increasing. If it was decreasing, it would go -5, -6, -7, -8. Got it? Yeah. This, when your graph is concave down, your slopes, your rates are decreasing. Write this down again. If you see your rates are decreasing, you immediately say, oh, I'm concave down. Because you got 5, 4, 3, 2, 1, 0, -1, -2, -3, -4, -5. That creates a curving down graph. Decreasing at a decreasing rate looks like that. Okay? So, go here and look at that. And you can answer this now. Decreasing at an increasing rate is decreasing concave up. If my rates are increasing, my graph is curving upward. Decreasing at an increasing rate is decreasing concave up. -2 to -1 is our answer. Here's another question, new question. When is F rate positive and decreasing? Once again, guys, if you got the first 3/4 of this lesson and you understand like going up and concave down, I'm asking you the same question. It's just worded in terms of slope. And if you understand our interpretations of our slopes, we should be able to translate this into going up, going down, concave up, concave down. Okay. What is this asking you? Where is the interval? Go. I just did F is decreasing at an increasing rate. So, hold on. You're saying what a previous question? Yes. This question that I just asked you is the exact same as this question. The answer is 2 to 3. Okay? F's rates are positive. When slopes are positive, the function is increasing. F's rates are decreasing. When slopes are going down, you're concave down. If you pick this up, you're good to go.
2 to 3 is also
Yeah, so 2 to 3 is increasing concave down. Increasing concave down is the same as when our F rate is positive and decreasing. When are my slopes positive, I'm going up. When are my slopes decreasing, I'm concave down. Combine the two. When our F's rate increasing, this is translating to F is concave up. When our F rate negative and decreasing, that means F is decreasing, the slopes are negative. When the slopes are decreasing, F is concave down. You translate this to F is decreasing concave down. If rates are decreasing, you're concave down.
But it has to be positive, meaning that it can't.
Increasing concave down. Maybe. It all comes back to your parabola. What's up? Okay. All right. Thanks. All right. Good. Thank goodness it's the last period. This is increasing at a decreasing rate. Yep.
Decreasing, right?
Decreasing at a decreasing rate.
Decreasing, right?
Yep.
And increasing.
Now you have to say slopes are positive or negative and decreasing. Like combine it that way too. It's a third way of asking the same thing. Okay. B-Day mornings. Just tell me. Like tomorrow morning, the next B-Day, whenever you want.
Okay.
Monday, Wednesday, Friday.
I'm busy the rest of the week, like morning and after.
Okay, Monday. Cool. Later. All right, combining things, what is F? Negative and decreasing, negative and decreasing, negative and going down. So remember, going up, going down, going up, going down. So -1 to 0, 3 to infinity. When is F? Positive and increasing. I'm above the x-axis and going up. -3 to -2, 1 to 2. All right, increasing concave up. Let's make sure we understand concavity. I'm going to say we are concave down. We switch to concave up. We switch to concave down. I would say we are increasing in concave up. Only here, this is my portion where I'm concave up. I'm increasing in concave up here, 0 to 1. Increasing in concave down, negative infinity. So here's my concave down parts, negative infinity to -2, and 1 to 2. All right, I'm going to ask this question differently. When are F's rates negative and decreasing? It's the same question really as what was just there. When are F slopes negative and when are F slopes negative and getting more negative, like -1, -2, -3, -4? You should be thinking, oh, F rates are negative, I'm decreasing. F rates are decreasing, I'm concave down. When slopes are decreasing, I'm concave down. So decreasing concave down, where do we see that? I see decreasing concave down here. I see decreasing concave down here. So -2 to -1 and 2 to infinity. What is the rate of change of F decreasing? So when the slopes are decreasing, F is concave down. Think about slopes. If they are decreasing, 3, 2, 1, 0, -1, -2, -3. Slope of 3, 2, 1, 0, -1, -2, -3, concave down. Okay? So when are we concave down? We are concave down from negative infinity to -1 and from 1 to infinity. When is the rate of change negative and increasing? When the slopes are negative, F is decreasing. When the slopes are increasing slopes, -3, -2, -1, 0, 1, 2, 3, and concave up, -3, -2, -1, 0, 1, 2, 3, concave up. So this question is really asking what is F decreasing concave up. I'm just asking it a different way. Decreasing concave up is -1 to 0. We can have the same questions asked to us, but just told about the rates of change. When is my function concave down? I know my function is concave down when my rates are decreasing. My rates are decreasing from 3 to 4 and 4 to 5. We don't know what happens right at 4, so just so it knows. When is F increasing? When my rates are positive. When my slopes are positive, I go up on average this many y's per x. So when my slopes are positive, I got 1 to 2, 3 to 4. How many points of inflection do I have? I have 1. That's 3. When am I decreasing concave up? If I'm decreasing, my rates are negative. If I'm concave up, my rates are increasing. So when are my rates negative and increasing? Oh, right there, negative and increasing, 2 to 3. Look at this table. Look at the rates. Down 1, down 2. My rates are negative and decreasing. So that means I'm decreasing concave down. My rates are negative, I'm decreasing. My rates are decreasing. My slopes are -1, then -2. I got to go concave jowl. Okay? I think this one's better than the other classes. Hopefully you understand, and if you don't, rewash this.